So while Brian's doing that, and Brian, I know you have this problem, and I hope the Twitter Spaces folks are like hearing this, but I am like unable not to click when I see a space happening. Like I've realized that this is actually a deficiency I have now.
So that you always go like space shopping. So you will always.
Oh my god! Yeah. No matter how no matter how tedious the title, like I'll click. Like you don't even need a clickbaity title. Like I am.
But you get this like halfway state where you can kind of like stick your head in the room and see who's there, and then decide whether to stick around or not.
Oh yeah, I mean my other pathology. First of all, I do this typically while trying to attend to a 3-year-old, so that doesn't go so good. And then second, Brian, I know you have this problem too. I find myself ducking in and out, right? Like I try to put it down. I'm like, that's it. I'm not interested. And then I set down the phone.
Well, okay, so I also am like petrified. I wish that, I mean, I obviously get a lot of requests for enhancement for them, but I also I find that I become accidentally load bearing in spaces that I enter. Where and then all of a sudden, like I feel like I was just here for a second. But now I feel like I kind of can't leave. I gotta like stick it out, and which I think has made me a little bit too selective on the spaces. If I had a 3-year-old, of course, my existing options would be so poor that I would be going into every space I can find. I mean, I think that's a very natural toddler parenting technique. It's like, please.
Oh, you guys are talking about licenses? Oh yeah. This is more.
Oh, this is way more interesting. Oh yeah, no, go on. This is like, absolutely. If someone is reading Hacker News comments aloud to me, yes, I'm here for this. This is much better than a 3-year-old.
Don't get me wrong. Some of my best friends are 3-year-olds.
Oh man. And you've got a real 3-year-old. Like you've got, Adams. I mean, God love Joshua. But so first of all, you should know that whenever I'm on the phone with Adam talking about work or whatever, Joshua is usually berating you from the other room, asking if you're talking to me. Like
he's like, who are you talking to? You talking to that guy again?
You know that guy again? Like hang up on him. You're like, hey, listen, kid. Like I know.
I mean, fortunately, we're sort of emerging from this pandemic life, but the number of times I've needed to apologize to people I'm interviewing, explaining that my naked 3-year-old really needs to wave before we can move on with the interview.
And it's just easier to let the Wookiee win on this one. Like, I just look, 100%. If you could just let the naked 3-year-old wave to you, please. It's going to be faster. Yeah. Faster than the alternative. Yeah. Well, as always, we want to make sure we get new people in here, new voices, what have you. So just like we kind of call on folks who we know are here that we know from other spaces, but definitely don't hesitate to raise your hand and hop in here because we definitely don't have much of a set agenda.
And so, Brian, we said we'd start with this writing a Linux debugger. Where I assumed that you had plucked this off of the top page of Hacker News today or something, but I didn't see it there.
I saw this. Okay, so is this a trap? Do I have to like reveal where I came across this? Because
I didn't mean it to be.
Okay, a trap, so look. I've been spending some time on lobsters. What's wrong? I feel like lobsters, for whatever reason, feels like Hacker News feels like a gateway drug to lobsters. It feels like the much more distilled, hardcore Hacker News. Anyway, I saw it on lobsters, and I think I also saw it on the Twitters. I feel like people were tweeting about it recently.
Yeah, but I've been on both of those places. I don't think there's any shame in Twitter or lobsters. We've all been there.
We've all been there. So yeah, I saw this. It's an older piece, but it was just making the rounds. And it's good. It's a good little series. For a bunch of reasons. I mean, it starts out with ptrace, of course, because you have to. But I feel like we can get in and out of that pretty quickly. Ptrace sucks. Next, moving on.
Yeah. We promised ourselves this wouldn't just be the /proc evangelism space again.
No, I think we already did that one. But
that's right. Maybe twice, but that's okay. Not a third time for sure. But I don't know if you had this. So you wrote a debugger. I mean, arguably multiple debuggers.
Multiple debuggers. I feel many. Actually, I feel that I'm on at least my third debugger. No, fourth.
Yes. Oh,
I'm on my fourth debugger.
I wasn't even counting the one you were working on currently. Jeez.
Yeah, okay, please.
But was MDB the first debugger you worked on?
No, I mean honestly, I feel that Threadmon at school was the first debugger I worked on.
Oh, Threadmon, right.
And having to, I just like I've spent my career writing software to understand software.
Yeah.
And I
Right,
can't
right.
get that out of my I can't get that out of my marrow. I think that's just like I and I don't know. I think other people have got a better ability to deal with complexity in their heads. I just have to like understand what the software is actually doing. So I think I'm just like
I don't think that's probably true, Brian. I mean, I think that like the complexity of like I think it is very unlikely that people are actually holding these things in their head. I think it's much more likely, I don't know, that people are using these tribal patterns or this kind of cargo cult debugging rather than getting to the root cause of these things or being satisfied until they get to the root
well,
cause
I
of
do
these
think that with software systems, it's really hard to know what they're actually doing.
things.
And I mean, so I do feel like my first exposure to this was actually as an undergrad. So I worked on this on a debugger, actually my first debugger. Although actually, I want to say it's my second debugger. My first debugger, I wrote something that I thought was extremely clever at the time called Sift that that plowed the plits. So you could the plits, the procedural linkage table, and I would have this thing that you would LD preload. It would overwrite the plits with its own indirection table, so you could see all of the dynamic library calls you were making, which I thought was fun and useful. But so the thread one was I built that as part of my thesis project to understand this whole multi-level threading model where you have many user-level threads on top of fewer kernel LWPs, lightweight processes. There are all these assertions being made, and no one had written any tooling to actually understand what the binding was between a thread and an LWP. And I don't understand how anyone could actually like build a system or make all the assertions they were making without having built that tooling. And indeed, like not hugely surprisingly, when I built that tooling, it revealed, of course, you turn on the light and it's like, yeah, this thing is not doing at all what anyone thought it was doing. So anyway, I would say that was the first debugger, and I was having to do all sorts of just dirty things to get to. I mean, dirty dog, dirty. I was like dirty in a way that felt exhilarating as an undergraduate. You know what I mean? Like whenever.
Yeah.
Yeah, I've got a 16-year-old now that has, like all 16-year-olds, has an impaired brain and is unable to make proper decisions. And I try to remember that, like, actually, I've got my own track record of terrible decision making, and I feel a lot of it is back there at that project. But in particular, I can't even remember how I thought this was a good idea, but I ended up mapping debkmem read write and effectively participating in the TNF locking process. I realized like I could just kind of like plow, which
wow, yeah, that's exciting.
Oh, it's very exciting and so stupid, and I can't even remember why I thought that was the only way. But I was using TNF, which is this trace normal form. Did you ever use TNF? I know we've had this conversation. We had this exact conversation.
No. I feel like I only was in TNF to get directions to get away from TNF. I think I was only there literally as we were like retrofitting dtrace components like into some of those existing like hash define invocation.
TNF, which stands for trace normal form, it was a facility in the operating system that Adam's charmed life meant that he never actually had to use. But it was really, really rocky. It was very hard to parse. It was written, and I think this is like part of the problem with debuggers. And this is like everyone can like raise their hands and just dogpile me where you disagree or whether I say that this is overly provocative. Debuggers are historically written by compiler folks and not systems folks. And not to be like not to create kind of an overly false dichotomy, not to like turn us against one another into tribal warfare. But I do feel that that debuggers as a result are designed to debug the problem that compiler folks have the most familiarity with, and that's a compiler.
I think that's absolutely true, irrefutably true, because those are the problems that they're most familiar with, and probably the problems that they have and they're facing on a day-to-day basis.
Yeah.
And I think that I wandered into the middle or the middle of like your journey in Solaris through a bunch of these debugging phases, of which like dtrace was one, but before that MDB and CTF and some of these other pieces. But all of those really motivated by the unobservable problems that you had seen. I mean, that you had experienced. Pardon me.
Right. Well, and I think that like debuggers are just not. They're designed for like reproducible problems, way too frequently. I mean, and like I love the blog series that we're kind of kicking this off with. I think it's great. And I mean, I really like it, but it is definitely designed around in situ breakpoint debugging. And I just view in situ breakpoint debugging as kind of like one sliver of debugging that's useful for one particular and somewhat unusual class of bugs. That's actually not the kind of debugger that I want to use most of the time.
Well, and in particular, that interactivity. And I think that in his like, where there's a human in the loop on every decision point. And I think in the last section, the advanced topics, I think starts to allude to the scriptability or automation within some of this debugging. And I think that's where that's where things get really interesting. Where even something like truss, when you're running truss using breakpoints to examine userland processes, you're still able to do those breakpoints programmatically where things are happening in multiple threads without the human needing to hit continue, step out.
Yeah, right, exactly. That as soon as you have the human in the loop, I mean, you necessarily stopped the system. And as soon as you've stopped the system, there are certain problems you can no longer reason about.
Yeah.
But all right, so what was your first debugger? As long as we're talking about first debugger,
Yeah, I mean, I think it really was the work in MDB. I think that when
I'm trying to give you the Libdis alley-oop.
No. Well, fine. Okay,
that's not a debugger. Wait, okay, no, seriously, what is a debugger then? Honestly, what is a debugger?
No, I'll take it out. I think I have complicated feelings about Libdis. So Libdis was and here's the alley-oop back. Brian's great idea. That was my intern project in 2000. So a long time ago. But the concept was we've got all this program text laying around.
Are you there? I muted you. I accidentally hit the wrong button. God damn it, Twitter Spaces. I tried to scroll down and I hit mute everyone.
That's good. Okay. So Libdis was the idea was rather than just taking the binary, the bits associated with instructions and dumping them out as ASCII for humans to understand, rather interpret them in some structural form so that you've got like these components that you can manipulate and then try to infer different things about the program. So for example, watch where values flow through registers and are transferred in and out of memory and passed to different functions to be able to do stuff like say, where did this value come from? What did it used to be? And not rely on like the compiler, not rely necessarily on the compiler leaving around those tidbits in Dwarf or in other places, but rather to be able to infer that just from like what you saw in the program text.
Which is what we see. Like it's like Ghidra. Have you played with Ghidra yet, by the way, Adam?
No.
I thought Laura was here. I was trying to scroll down because Laura was here, and then that's when I literally Twitter Spaces. The button I need to click on the additional people that are here is underneath the mute everyone button in some act of total cruelty. I cannot see who else is here, but Laura was here and she's used Ghidra a bunch and used that to ultimately to really aid in this vulnerability that we found. The LPC35 vulnerability. But I feel like Libdis was like a proto Ghidra coming. It's like the RE community, the reverse engineering community, is in a lot of really interesting stuff that I think we should be using in debugging a lot more.
Oh yeah, I'm struggling to remember, but there was this reverse engineering tool that had to do with like memory analysis that a colleague of mine at Delphix used for debugging purposes and kind of submitted to their conference, but it really had not been used in that way before. But I agree that there's a ton of crossover, in particular when it comes to this, these hacking tools for applying them for understanding complex pathologies.
Okay, so let me ask this. I meant this question earnestly. What is a debugger? Because I realize that because I feel dtrace is a debugger, but maybe I'm the only one. Do you view it that way?
Dtrace is absolutely a debugger.
Okay, good. Right.
Yeah,
so at least two of us view it that way. But I don't think like most people view it that way.
Well, then what is debugging?
No, that's what I mean. But this is what I mean. Like, I feel like it is a debugger. I feel like it's a kind of a regrettable term, actually.
That's interesting. You're right, because it does connote a certain activity, which is like the software engineer building the code and trying to understand, in some ways, de minimis problems as they do that.
Right.
Whereas, but then it's kind of a very natural stepping stone to go from that to more complex issues, and more complex environments, and so forth.
But I feel that like you want some. I wish we had a term that was aiding us in the understanding of what software is doing. I agree that's like complicated. That's too many words. I mean, the debugger is a much shorter term. But I feel like as I'm thinking about it, I think that's kind of like part of the problem.
You're right, and it's not necessarily the moth flapping its wings on the transistor on like the relay or whatever, because it doesn't. It implies a problem when there may not be a problem. It may just be, I want to understand how the system is operating, independent of whether it's doing it badly.
That's right.
Isn't the term for that introspection?
Right. Yeah. I mean, like, yeah, introspection, or like, it is, what is a CT and an MRI and a PET scanner are all what? Those are all
diagnostic tools.
There you go. Yeah, I feel like so it's I don't know. I feel that like the term is a bit of a hang up. Anyway.
And we can't really take observability because it means something a little, I mean, I don't know, it's nice and it's close enough, but those folks have really owned it.
Yeah, you're kind of trolling the hell out of me on this one, on observability. Just because I feel that like, if someone was using observability to talk about software before I don't know who it was. Like I don't know where I got that. and I'm not trying to be like self-aggrandizing about it, but the people go to observability and then they go to the Wikipedia article for observability, which is a control theory article. And so they talk about observability, and which is a mathematical property, and that's not what we're talking about. This is not a mathematical property. Observability is our ability to see software, as far as I'm concerned. So, I mean, to me, like, PS is a diagnostic tool.
Yeah. Is that a debugger? Yeah. I mean, I think I agree. It's a diagnostic tool. It definitely stretches my mental model for what is debugging. But you're right. Like in part of a debugging endeavor, you're running PS, you're running ptree, like you're like all of these things let you see what the system is doing.
Well, and I swear, I mean, with the debugger that I'm currently writing, which is for our embedded all Rust system Hubris, appropriately enough, because we're doing a de novo operating system, I am writing the debugger appropriately enough humility. And just like the ability to get a task list out of the system has been really valuable. That's a very, like, you can debug many problems by getting an annotated list of tasks. And like with MDB, being able to do a : PS was super valuable. But
the analogy with MRI or CT or whatever, I feel like is really appropriate because it must have been in the nascent days of those technologies that you could find all kinds of pathologies and etiologies that were just not observable before. I mean, in that case, very literally. But like, but each one of these new tools, I remember, a formative moment in my career. I was probably 22, 23, using dtrace with a Sun customer on their application, and just, I didn't even understand what I was looking at, but it was so valuable to them. Their jaws were on the floor.
Were we together at Walmart doing a demo? When we were doing a dtrace demo, and we are like running dtrace on their system, which is great, right? As you're pointing out, it's always so much fun to like look at someone else's app because you're like, I don't know what I'm looking at. Like, yeah, I don't know. And they're like, oh my God, we've never seen this before. Like that calls this other thing. Like that's it. And so I was doing it on their live system, and they were guiding me a little bit about like, how to aggregate and where strings were hiding out. And we got to the point where all I remember is like one of the the result of this aggregation that we had was like, they were like departments in a department store. So they were like lawnmowers, like ladies lingerie, 15, like raincoats, 142. I was like, wow, this seems really cool. And one of the guys at the back then was like, there's a bug in dtrace because that output is wrong. And I'm like, I don't have like, men's raincoats is not like output that we generate, by the way.
Right.
Like that's not.
If you strings the dtrace binary, you're not going to find any mention of raincoats.
There'll be no mention of raincoats. He's like, well, it's impossible because like those two systems don't talk to one another, and there's no way that system can be. I think we were aggregating by IP address in that one. He's like, those systems don't talk to one another, so your thing is generating the wrong IP address. I'm like, it feels unlikely. I mean, I'm not going to say it's impossible that it's a dtrace bug. And then you could see his wheels just like grinding for like 5 minutes in the back. And Brian's like, actually, I know what's going on. That's actually a really serious issue that we need to understand. He's like, but I think I know what's going on. And those two systems should not be talking to one another. So it was just like one of these things where it's just like, and I had a really interesting conversation with Cliff Moon. I don't know if you ever met him, but he had this company, Boundary.
Yeah.
That was doing a bunch of network observability. And it also is like the super basic observability that we are really, that is still too uncommon about like just what's talking to what. Because I think you can learn so much. I mean, I'd be curious to know to what degree people use those kind of tools on a regular basis, because it seems extremely valuable to be able to determine what's talking to what, because you can see like, wait a minute, like this database rollout that we thought is happening is not happening, or it's not being phased, it's happening too quickly, or it's happening as we thought it would, which is very reassuring,
One of the interesting lessons though that occurs to me is that as the debugging tools get more sophisticated and customizable and require more, I don't know, sort of programmability or intervention, it also opens the door to really drawing the wrong inferences, or to getting, to think you're seeing something, but actually having measured completely the wrong thing. And certainly, I mean, I've seen this, as recently as yesterday with dtrace, where I was working with someone who had written a script. They thought they were looking at one thing, but in fact, were looking at another. It also calls to mind like bad debuggers I've worked with in the past, which have violated what I think of as the cardinal rule for debuggers, which is don't kill the patient.
Oh, okay. Yes, don't kill the patient. That is actually okay, yes. I thought you were going to say the cardinal rule was to not lie. But actually, there is a rule that's more important than not lying, which is not killing the patient. Like, actually, right. If you have to choose between killing the patient and lying, maybe you should lie. But hopefully, don't kill. Did he kill the patient? No, what killed him?
Oh, well, this was years ago. I mean, I was using a debugger that I'm not going to mention because I feel like I'm sure it has evolved since then, because this was kind of the early days of Go. But I had some process that was spinning out of control. I had no idea what was going on with it. And then at the time, it's one of these batch jobs I was running that was like in hour 7 of 23 or something like that. And someone was like, use this debugger, and I poke it at it, and immediately all the walls started crashing down.
Oh,
so
no.
Like, you know what? It didn't just pull down itself, right? It pulled down everyone else with it. So
that is bad. What happened? Do you know? I mean, unfortunately, like when something like that happens, you're like, I don't even want to debug it, because I just am never doing that again.
Honestly, that's where I was. I was like, you know what? Like, fuck this thing. Like, I'm never running this tool again. And I may never write Go again. So
not killing the patient. This is actually a really important thing, because I think that this is something that it was always an principle for us.
Yeah.
And you don't get any free kills of the patient in production. Like if you kill the patient, no one is ever going to run that again. And it actually doesn't matter how much. And it's just like you're saying, it's like, I'm sure it's improved since then. It's like, well, maybe it has, maybe it hasn't, but you're not going to know, because you're not going to run it again ever.
That's right. It's improved for someone else, because it hasn't improved for me. Right.
Yeah, it's like, I'm not going to let it kill. I can't do that. I can't let it. And not killing the patient can actually be harder than it sounds when you are not trying. You're trying to do production debugging, not in situ debugging in development. I mean, it sounds obvious, but it's not like it's electing to kill the patient. It is controlling the process, and then presumably it's the debugger died, I would assume.
Yeah.
The debugger tossed while its target was in some like either non-running state, or it died in such a way that it brought its target down with it.
I mean, it's there are trivial examples of this, right? I mean, even in this great blog post that we're talking about, you're talking about how you write breakpoints, and you write breakpoints by scribbling over some program text with a hex CC or a breakpoint instruction or an illegal instruction, whatever, and remembering what instruction was supposed to be there. Well, now if you, the debugger, die, then along with your death goes the knowledge of what those instructions were supposed to be.
Yes.
And it may even be that I've set no breakpoints, but the debugger is interested in knowing when dynamic libraries are loaded, or when you fork a process, or when system calls happen. And so once the debugger's dead, if any of those turds are left around, then I've got a time bomb of a process.
That's right. And you've got a sig breakpoint. You've got a signal that you don't see very frequently because you're not supposed to see it, which is that you hit a breakpoint when you've got no process manipulating you.
Yeah.
So the kernel kills you, and you're like, "What the hell just happened?" Yeah. It's just one of these. It's super easy to kill the patient. Is the problem? The problem is when we're debugging the patient, we are actually taking the patient in and out of death all the time.
Well, that's right. I mean, in some ways, the paradigm of debuggers, from ptrace and then espoused and then carried in lots of other places, is a little bit busted, right? Like the thing, like. The notion that the debugger is now become load bearing in the execution of the program, is a pretty grave responsibility, and obviously with dtrace, I mean, both because we had to and because it was the right way to build it. Stuff like the original instructions associated with a particular address in a program live in the kernel, but there's no reason why there couldn't be a breakpoint facilities or debugging facilities that are built into the kernel or sort of glued onto the side of the process, so it was its own fault boundary.
Well, so you're highlighting another challenge, I think, for debuggers that I think the size piece also highlights, which is that part of the challenge. Because one of the things I ask myself, you must ask yourself this as well, is like, why is our debugging technology not better than it is, or why is the better technology that we have not more widespread than it is? And I think, to make this very concrete, it is a tragedy of our domain that we do not debug postmortem routinely. The fact that go ahead, fully vaccinated Nate.
Yeah, I didn't mean to interrupt, but this is I kind of forked off on this thought a little bit earlier when you were talking about something else, and then you've kind of come back around to the same thing. So it's actually pretty good timing. But my thought was how you're talking about the early debuggers and things that you worked on many years ago, and those of us that are old enough, all computing was single-threaded on a single machine. Now most computing is not. Distributed systems and debugging them is obviously a whole different ballgame. But exactly what you're talking about, how debugging technology has not kept up with that. These are always viewed as like transient problems. They're horrible to try and reproduce the conditions for after it's been observed. There's telemetry for tracing the path of a call through a distributed system, and that helps a lot. But it can still be it's just really complicated and really difficult to set that up. But debuggers and introspection tools in general are automating exactly that, and we just haven't kept pace with the current way that we do architecture with those tools. And I'm wondering if anybody has any experience with things like that in a really complicated environment. And the thing that started me on that path was thinking about, you said, cardinal rule being debugger should not kill the patient. Well, what if interfering with it does kill the patient because it's waiting for a heartbeat or interaction with some other system?
Yep, absolutely.
And those are fiendishly difficult to work around when you're trying to observe it. And it may be, very Heisenberg in the way that when you go to observe it, it literally avoids the problem.
Absolutely. Which is part of the reason that I have always, I wish we spent more of our caloric budget understanding the carcasses of dead programs. Because a dead program, the program has died. It has panicked in the Rust sense, or in the Go sense, or it has an exception. It's like the program has incontrovertibly encountered a programmer error. We throw away that state writ large.
We do, and I think part of the reason is that at some point, those things are driven by, business metrics. And at some level, all problems are transient. All problems are ephemeral at some level, right? This computer architecture is going to go away. This program is going to go away. This platform is going to go away one day.
Yeah,
How bad
I don't know. You got credit card processing code that's been running since the 60s.
Yeah, and I also feel that, like,
true.
can't you just, like, go to the existential crisis way of explaining away anything? Can't you be like, look, yeah, it's true. It's like the plane crashed, but our lives are meaningless. I mean, we're...
That's right.
That's
on a live enough
when
time scale, all of our survival goes to zero, right?
Yeah, but I guess what I'm saying is when you go to ask for money and time, which is
true.
money.
Yeah. This is a very good point in terms of it is very hard. And I think that engineers do not feel empowered to build or buy or invest in the tooling needed to debug future problems, and because they feel that they can't justify it.
Well, right, and it's actually very sad to us to think that there are problems that literally may just be practically impossible for us to ever solve because the world will have moved on, before it's justifiable to solve that particular problem.
I can hear Dan getting in here. Dan, yeah, go for it.
You also have to kind of define what exactly you mean by a bug, right? Because, I mean, kind of an off by one error where you go off the end of an array in C or something like that, that in some sense is kind of trivial. If you have a stack trace, you can usually just kind of figure out what's going on and fix it. But, if your bug is, gee, my program doesn't run fast enough, then that's a whole different can of worms. And, to my mind, I think a lot of that sort of, the former category of bug, these things are better addressed through aggressive testing and better engineering practices that we've just completely, not developed from scratch in the last 20 years, but, definitely the industry has changed from when I was a young pup, running around on Vaxes and things like that. And, now that stuff is done as a matter of course.
Yeah, that's a good point, Dan.
Yeah, so a lot of bugs just don't even make it in. But the sort of visibility tools that you're talking about, like dtrace, to me, these are much more useful for addressing that latter category of bugs. It's like, my thing is slow, or there's some random slowdown. What the hell is going on in the system? Give me some visibility into the kernel to let me know what's happening so I can try to figure out where the performance is going.
I'd say there's always a difference between performance and unexpected behavior, though. That's where I would define a bug as unexpected and undesirable behavior.
Oh,
where,
absolutely. Yeah, performance is just a contrived example. Yeah, performance is just an example.
Make it work, and then make it fast, and then make it beautiful, right? So you kind of expect that we're by default in a working state, and it might not be as fast as we like.
Yeah, performance was just an example. I mean, that's, there are any number of such things where it's like, what the hell is going on in the system? It's not crashing, right? It's not like there's a core dump sitting there that I can go poke at, but the system is behaving in a way that I didn't expect it to, and I want to know why. And tooling around that is really valuable. But tooling,
yeah. Well, I was just saying you're off by one error, though. Which on the one hand, yeah, there's certainly a class of errors on which a stack backtrace can be enough to understand what's going on. There are many other classes of errors where the stack backtrace ends up being symptomatic of what's a deeper problem, that you're actually off by one for deeper reasons than merely, in other words, that you can address the symptom quickly, but to understand that root cause, you actually need more of the surrounding state when the program failed. I also think you're making a very interesting point, and an important one about because it's true that CI/CD, I mean, the whole idea, all of our pre-production work has gotten way better than it was when we were all pups. And I think that's compensation for the fact that we can't understand these systems when we deploy them. I mean, I think it's good. It's the only way in other words, that is the only way we've been able to build systems that just work at all ever.
That's interesting to draw that.
I mean, look, I hear what you're saying, but honestly, you could give me the most magical, amazing tool that could tell me everything that's happening in my system tomorrow, and you could pry my CI/CD, and more importantly, my unit tests out of my cold dead fingers.
No, totally. No, right? I'm not saying it is definitely not a substitution for unit tests, and it's not a substitution for CI/CD, which are great developments. But it's more that I think that part of the reason that development has been so rich and productive is because it's been the only way of assuring that we don't introduce new defects into production.
Yeah,
I see what you mean.
It has been a very significant change in the last 10, 15 years. Totally agreed. And I think that's a great point, Brian, that the absence of understanding has driven that need or accelerated that need for doing early integration unit testing in a more comprehensive way. And it is a disappointing gap that we haven't seen tooling come along with it. And tooling to understand some of these pathologies that we expect to see in environments, both general tooling and specific tooling for understanding some of these more specific pathologies.
Have I somehow talked myself into a position where a lack of debugging has actually helped advance civilization? I'm very concerned with what
I'm gonna go back to my question. What is a bug?
Oh, totally. I mean, I think it is undesirable behavior. I think part of the problem is part of my problem with the nomenclature of a debugger is you don't necessarily know the undesirable behavior in your system if you can't observe it, if you can't see it. If you can't look at it, you don't actually know what's wrong with it necessarily.
Yeah, I think that's right. It's any unintentional behavior, but it can have a whole class of, it can have many different outcomes. One of those outcomes is no effect at all. It may be totally unobservable with no consequence to the program. Other ones might be crashes or performance problems or correctness problems, all kinds of things.
If a tree falls in the woods, is there a computer that crashes?
I was going to say, this is where Brian's previous fieldwork example of showing somebody what their system's doing that they weren't aware of, it's not debugging anymore. It's introspection, but it's no less valuable. It's because like you said, the way we develop now is very different from 15 years ago, where you're talking about controlling your process, your unit tests. Well, the code that you write is like 5% maybe of the code you ship. People pulling in a dependency chain from NPM, I'd like to know what that's doing just with my skeleton program before I start doing anything crazy. I'd love to have some idea of what that looks like, and then actually do a comparative study of, well, what if I use this dependency instead of this one? Oh my God, that's 100 times better, literally 100. And that happens all the time.
Absolutely. And an interesting thing about that is that with the prevalence of tests, those become interesting examples of how you would use a third-party library. Like they have, pedagogical value beyond just like asserting that some modicum of correctness happens in the tightly controlled unit testing environment.
Sure, but then there's, like you said, there's unit testing, and then there's integration testing, and then there's like real-world testing with live conditions, and those are completely different things.
Absolutely. But what I think what I'm trying to drive at is that the move to testing has in fact obviated some of the need for what we would consider to be traditional debuggers. Oh yeah. I'm going there. The gauntlet is thrown, Brian. Feel free to share more.
Do I have I need to find an emoji that I can use over here? I need the Twitter Spaces. Is there a mallet emoji that I can use? Yeah.
Brian's in the process of firing me at the moment.
Exactly. When Jess has it hooked up to an API, so you'd be amazed how fast it is. It's really. No, it's interesting. I definitely don't agree with it because I feel that I've just discovered too many pathologies. I think it's too easy to say that when you can't turn on the light of that system that's deployed. You actually honestly don't know the problems that you don't know about. So what you are finding is kind of one very important class of problems, but you are then leaving totally dark another extremely important class of problems that are the ones that emerge in systems when they're more mature, when they're deployed in production, and when they're doing the most damage. Adam, I don't think we can get out of here without mentioning AA debug. The automated, so there's a conference, RIP, AA debug, the Automated and Algorithmic Debugging Conference, AA debug. And Adam and I were extremely excited to go to this conference. And they only had it every couple of years, which I thought.
I was thinking of it today because of Hopple, and it's
totally.
And it's cicada-like frequency.
Okay, so I thought AA debug. So Hopple has this cicada. I love that analogy. It has a cicada-like frequency because Hopple is such history programming languages. It is such an important endeavor for humanity. If we have it too frequently, we will spoil ourselves. I mean, it is that's. And I felt this was the same way with AA debug. It's like the Olympiad. You can't have the Olympics every year. It doesn't become special. We need to have it every. And what we didn't realize is like, no, this poor, hapless academic community is just being pooped on by everybody. They can't find a venue every year. They can't even they couldn't get it together every year. And so Adam and I went to AA Debug expecting to find just this glorious paragon of academic virtue. And we found a very strange room. I don't know, Adam, you want to describe what we found at AA Debug?
Well, the thing that I remember most starkly is there being this sort of test suite of excellence when it comes to automated debugging, program debugging, and it was some kind of pile of C programs with known bugs in it, and you would throw your new paper at it, and then it would find 84% of the bugs. And then there would be a lot of, slapping each other on the back on that, and really contrived, focused on the simplest of simple bugs, and debugging them in automated fashion. Which I don't know. I don't deny the right to pursue that, but I question the value of that.
Hey, don't forget
that's kind of what I was driving at, though, is that addressing those sorts of bugs has become uninteresting.
It is absolutely uninteresting, and it was uninteresting at the time, and it was really unfortunate. And then half the room were Prolog people. Don't forget that we had the ardent the Prolog, and who admittedly were spending a lot of interesting tooling on Prolog. But it was clear that it was a hapless community that did not feel valued in the broader academia. It's debugging is not something that is viewed as academically interesting.
But Dan, the problems that you're talking about, no longer being problems, or now being easy, or no longer being problems, they were sort of always easy problems.
Well, but they weren't, right? I mean, so I had a bug in a very large Lisp program one time that was only detectable at runtime because somebody tried to add a number to a string. Right, and in a strongly statically typed language like say Rust, that's a compile time error, right? And in a weakly typed language like C, you get a pointer, right? So the sort of better tooling and better languages and better practices have led to entire categories of bugs just disappearing from our landscape. And that's the interesting thing. And those are the things that used to be oh shit, my program, dump core, gotta fire up GDB and figure out what's going on. It's now you don't do that anymore. But in many cases, you don't have to do that anymore. And that leaves the more interesting landscape of these pathologies that you guys are talking about as being that's the really core interesting domain of, these visibility tools. I don't want to call them debuggers because I feel like that sort of has a connotation which isn't completely accurate.
Okay. Well, so on that topic of observability tools that are not necessarily traditional debuggers, Brian, I'm gonna lob a softball up to you to tell why we were at AA Debug and your paper in that conference.
Well, yeah. So I was very excited because I have always believed that we've got that a dead process has a lot to teach us, and in particular that when we have when the kernel dies. We have this, and especially if the kernel dies with memory corruption, we often give up on it. So when you see, and Dan, you've got your off by one example is fine if the entity that was writing off by one to that array, if that's the one that induced death, that's easy to diagnose. If that did not induce death and it actually some other thread died when its array was plowed with that off by one error, that's exceedingly difficult. And one of the things that we observed was that you'd be looking at a memory buffer that had come out of a pool of memory, out of a KMM cache in this case, and you could see the buffer in front of it that plowed it. And so the question is, who has this thing? Who has the buffer that happens to be next to mine? Who is my neighbor in memory because my neighbor just burned down my house, basically. And we would do all sorts of like just dirty stuff to be like, we had we still use something that just iterates over the entire dump, looking for where this pointer might be. Who has this address in memory, and what is it? And what
I need to pause you there, just because it's so crazy, and I just want to emphasize that he means what he's saying. We look for the 64-bit value and see where we find it. Okay, this is a game of bingo across the entire address space. Okay,
so because you feel that idea is so knuckleheaded that people would feel that their understanding was incorrect because it can't be that knuckleheaded.
And I agree. Like, I've used it like a ton of times to like save my ass.
Right, it's quote unquote K-grep. It's very useful.
Yeah.
That would be useful. And so what we observed is like, actually, we can know a lot about what the pointer graph is. And I love to do this for Rust, by the way, because we do so much on Rust with this. But we can actually know the types of things, and we can propagate those types through the system. So we can start out with the things that are in our modules. We know what those types are. We can follow those pointers and propagate types. And then you can actually have a chance of determining what is this thing in memory, which was super useful. It also had to do very dirty things to work around C. And in particular, you hit a union and you've got no idea what it is. This is why I love Rust, because when you hit an object in memory and it's an algebraic type, the discriminant is actually the part of the dwarf info for the object. You know what object it is you're looking at. So, it's kind of tragic that we can do all sorts of things from a dump with Rust, and we probably do need it less because we will have less rampant memory corruption problems in Rust-based systems than C-based systems. I think that's a pretty...
You're absolutely right about that. I mean, when we were working on the hypervisor back at Google, one of the first times that I realized that we had really made the right decision in writing this thing in Rust was, we walked off the end of an array. We were accumulating some data structure, and, on our test system, there were 5 of them, and on like a real system, there were 500. And, the array had space for 15 elements or something like that. And I still remember literally the hair on my arm sort of stood on end when I saw this. And it was like, we got a panic, and the panic said, sorry, you're indexing, 1 past the end of this array. Yeah. And it was exactly that phenomenon that you're describing, where it's like, okay, you walked off the end of the array and you didn't crash, but you corrupted something and the system kept running. And it was like, having worked in the world of weird researchy C kernels for a bunch of years, and then all of a sudden coming to like Rust, where Rust is like, no, hey, you just shot yourself in the foot. It was like, oh my God, wow, you can tell me that? That's awesome.
It is really, really nice. And it does mean that I think, and Dan, I think this is the point you're making that I definitely agree with, that certain classes of bugs, we have found other ways. It's great to have the forensic debugging, but the Rust eliminates a big class of bugs where you would need that debugging. Now, it leaves intact the really nasty ones. So I think the need for tooling remains, but the focus on that tooling needs to be necessarily on the nasty stuff rather than the easy stuff.
Yes. And no more of this weird GDB, I'm going to allow you to modify memory and then rerun the thing. And, oh, look, my program returned the correct result now. It's like, don't do that. Write a unit test instead.
I think that's a really, really weird trade-off that happens here as Rust pushes some of those, pushes people towards trying to solve those more difficult bugs and gets rid of a lot of the easier ones that, I think one of the biggest issues with debuggers is actually kind of a human thing, where comparing something like a debugger to something like println or printf, right? Everyone knows how to use printf. Printf is always there. Printf works across operating systems. People know how to use it. Debuggers are obviously more powerful, but they're more complex. And so there's this weird mismatch in a way between when you're faced with really, really difficult to debug issues, but the hurdle that you have to climb is learning a bunch of tooling first to be able to do that, I think is something that is a barrier for a lot of people to reach to debuggers as sort of the first or even second tool in a lot of cases.
Sean, I think you're exactly right. And I think especially when the thing you are trying to debug is the software that you yourself are trying to develop. And I think it's a mistake for people to denigrate printf debugging. Printf debugging is great. Like if you've got a situation that you can debug quickly with printf debugging, you should debug it with printf debugging or println debugging. The challenge is more, and actually I ended up as an undergrad had a huge, like, God, I don't know if I've ever told you about this, like this huge, gigantic department-wide fight, because this was during the object-oriented programming. Like, object-oriented programming gave rise to like these fundamentalists that believed that there was the OOP way to do it, and everything else was kind of the wrong way to do it. And in particular, adding printf to your code to debug it was the wrong way to debug your program. So they would tell these introduction computer science program students, you may not add printfs to your code to debug it. You must use the debugger. The debugger was written, this is by Steve, a professor who liked to unleash the kind of the Dr. Frankenstein of programming tools, unleashing this kind of monster on the village. And this debugger was incredibly slow and incredibly buggy, and would often kill the patient. And these poor students are like weeping in the sun lab at 2 a.m. because they can't debug their programs because they're not allowed to use printf. And so we had this huge like blow up because those of us who are kind of on the systems track were like, you're doing wrong by these students. Like, they should be able to use printf is a valid debugging and an important debugging tool, because you are modifying your program to emit a datum that says that you executed this code, and that's an important tool. And Sean, I think to your point, it's like that is a tool that, like, if you know how to write this program, you know how to use that technique. You don't need to ramp up on anything else. Nothing needs to understand your program. You don't need any additional tooling. And indeed, being able to do that quickly, I think, is important. It's just that it's a tool that is not useful for all classes of problems. And by the way, Rust makes this amazingly powerful.
Apologies for just stumbling into the discussion, but there's only one thing I wanted to say is that when I was doing the Go port for ARM64, there was a particular bug that I was stumbling into, and it was a very difficult to reproduce bug. And basically, the only way we could actually fix the bug is we attach a debugger to a particular test that was running for about 3 months. And the particular test took about 3 months to reproduce. So yeah, in some sense, of course, you could do printf debugging because you could recompile the code and run it for 3 months. But the whole idea was that in those 3 months, you could observe the process, what it was doing, and decide what you're going to investigate next. And essentially, if you have a proper debugger, it's like you have a sort of dynamic printf. You don't have to recompile anything. You can keep running your test for 3 months or whatever, and then observe it for 3 months. And that's one. The fact that you don't have to recompile your code is quite a powerful aspect of having a proper debugger that you can have like program and things like that.
To be clear, I mean, I'm not trying to downplay the power of debuggers. I totally agree with you. Like they are like objectively more powerful than printf style debugging, right? Like, of course. You have more tools at your disposal. You have more control over the program. There's no need to recompile. I just think that it is worthwhile kind of looking at the, I guess, I hesitate to call it like empirical evidence, but I really do think that people reach for printf and logging style debugging before actual debuggers. And I do think that the human UX situation is a major aspect of why.
I would definitely agree that it's a human UX problem, and that the best way to deal about this problem is to actually implement better interface for debuggers and actually educate people how to use the debuggers, because GDB itself.
Oh God.
It's yeah. Well.
Oh God.
I think that kind of runs up against a problem that we were talking about earlier, where just because the better tools are made doesn't mean that the better tools are adopted. One time I had
Yes.
the opportunity to sit next to somebody on a delayed flight coming back from O'Hare. It was canceled. I just looked around, grabbed the 3 nearest people and said, let's split a car because we're all going back to the same place. And it just so happened that he was somebody who I had seen issue a patch to the PSPP statistical mailing list. And
were you coming back from a PSPP conference? How does that? First of all, I got so many follow-up questions. How do you discover this in the camera?
I mean, oh.
Yeah, so I used to work with at a social science place. I was the open source nerd. We learned about SPSS, which is a statistical package. I immediately went to the open source version, and so that's how I found out about that patch. It was. He was a professor at the University of Wisconsin, and he was coming back from receiving an award for a tool that he had developed that is the first, hearing about it was the first time that made me question what was a debugger. It would instrument your program so that every memory write also logged out to a stats table the values. And so then his paper that he was presenting was about inference of bugs through abnormal writes. And my first reaction was, well, that can't be a debugging tool because you don't know about the bug, right? There has to be a bug to be debugged. That was, I'm 23, I think, at this point. Since then, I've changed my position. But I thought this was like the future. I thought I had glimpsed the future, but it was some sort of mirror world that somebody else is getting to live. Because right after that was maybe 2005, 2006. And then right after that, everything hit the distributed issue that we were talking about earlier.
Do you have I would love to put a pointer to that paper actually in our Spaces notes here. Do you remember the author, or is there I hope we obviously try to find it based on how you described it, but how would we find that
paper? This was like 15 years ago. His name was Ben something. I can try to Google it. I'm sure he was a professor at UW for a while.
Okay, that should be enough for us to go on. We should be able to go figure that out. Yeah, interesting. Well, in terms of thinking that you've glimpsed the future and then not. And I think this is the challenge with this kind of tooling is that it requires so much specificity to make sophisticated tooling that you do end up with this least common denominator of GDB, which is, man, I try to be charitable with GDB, but GDB makes it so hard to be charitable to it because it's such a mishmash, and there's some stuff in there that's super valuable, but a lot of stuff in there that kills the patient, unfortunately.
Well, it's always the same problem. Is like there's never is the problem with the lack of features. Always the problem with lack of abstraction. If you don't have the proper abstraction, you do not. If it's not programmable, then you cannot do your thing, even though it has all the features. Like I'm absolutely sure that MDB has less features than GDB. It's just the fact that it's actually programmable and it can actually write a shared object that can program GDB. It simply makes it strictly more powerful.
Yeah, that's interesting. I also feel that with all of this stuff, I mean, the other challenge with all of this is that and Shauna, you were kind of making reference to this in terms of you're talking about the kind of the UX lift. You do need to get people to find their first bug using this tooling, and hopefully that comes quickly because the disposition changes towards tooling. Once you have found your first bug with this stuff, you begin to reach for it earlier and earlier and earlier, and there are more and more classes of problems you can use to find it.
It's a great point, Brian, and one of those things is it's so hard to motivate the education of a tool that can have the perception of a high ramp to learn without an actual burning need. And then once you get them past that first experience, then you've demonstrated that investment is worthwhile. But when you don't have a bug to debug, it can be really hard for folks to grab onto new technologies that have a ramp.
Yeah, I mean, and we certainly, we've seen this over and over again. I mean, I've seen this with everything I've ever developed. I would say it's been fun to kind of replay history with humility with this current debugger I'm developing, and watching my coworkers kind of use it for the first time to debug a bug that they wouldn't have debugged otherwise. But it takes a while because it's the time to learn something new, it's like, no, I'm dealing with a house fire right now. It's not time for me to learn something new. Like my house is burning. I want to focus on that. It's like, no, I know your house is burning, but we actually have a more structural way of understanding some of this stuff. But it's tough. It takes a long time for people to kind of to get there, and justifiably so.
It also requires a fair amount of infrastructure. I mean, one of the, going back to the whole idea of printf debugging, there was a time we were playing around with the Nova hypervisor, which had kind of atrophied. It'd been on GitHub for a long time. It's 32-bit only. Blah, blah,
right.
blah, blah,
Yeah. Right.
Well, so we were playing around with it and trying to get it to go, and it was crashing, and we weren't exactly sure what was going on. And like one of the most powerful debugging techniques, especially early on in boot, before anything was really set up, was basically, ASM volatile halt, and then inside of QEMU, info registers. Which I think is very similar to the type of debugging that one would do with like a dtrace or an MDB or something along those lines. But in the sense that you're inspecting the state of the system. But it's like you just didn't have any of the infrastructure to be able to do anything like that, because the system was still in this embryonic state.
Absolutely, and you've got to be able to think about, what can you add to the system to make that a faster and better experience, to extract state, not necessarily dynamically, but like, early on in boot is a great example where, you don't have, often you just have like, LEDs, or you've got GPIOs, right? You're just kind of pulling GPIOs in various directions and then trying to infer your state that way. And that is where the in-situ debugging can be useful, but I certainly, we have seen this. It is always interesting to watch someone kind of hit that point where they are starting to use the tooling, because the enthusiasm level changes quite a bit. Notice historically.
I got to share. I had a great experience this week or last week where I was showing a colleague MDB for the first time on a real bug, a real problem they had, and running commands that I forgot were my fingers. I hadn't run them in 5 years. And then being able to step back and ask the question, how would we have seen this with other tools? And it may just not have been observable. It may have been the kind of thing where you kind of read the tea leaves and make some changes and hope things change on the other side and they were related to the changes you made. But there's nothing quite like driving one of these unknown issues actually to the root cause. And it's so satisfying.
It's very satisfying. The proof of a debugger is in the debugging for sure. And it's like actually finding issues with stuff that you learning things about your software that you wouldn't have found otherwise. I also do think, we'd be remiss to not mention all of the open tracing efforts that have happened. We have seen an explosion in software observability that I think is all extremely positive. I think it's still a challenge to actually use all of that stuff, but it's all steps in the right direction. It feels, I don't know, Adam, I really would.
Yeah, no, I think that's absolutely right. And I was thinking through this whole conversation that I buy Dan's argument that the argument that we've come to, that some of the lack of observability or the lack of folks being able to understand their systems has been one of the strong motivators for rooting out some of these problems earlier with CI/CD and test-driven development and all these kinds of practices. And I've been wondering, the same observation. We see stuff like Observe or Lightstep or whatever, but it just doesn't feel like we're quite over the precipice where debugging and debugging infrastructure and tooling has become just part of the process, the way the testing has.
Yeah, you're right. We have not hit the CI/CD point. I'm not sure when we hit that with CI/CD, but we were indisputably past that fulcrum, and we're not there on open tracing, I think.
I must confess one thing. The reason I ported Go to Illumos in 2003 was simply so that I could run dtrace on Go.
Yeah, God bless you.
That's great.
Yeah, it is actually, it is very nice. I have to say, with the static languages, the dynamic languages make it really, really hard to dynamically determine what's going on. And dynamically instrumenting dynamic languages effectively requires VM cooperation. Adam, do you remember our brief love affair with Parrot?
Yes,
yeah,
yes, absolutely.
You remember? Aaron remembers all of it. So Parrot was this VM that was going to rule all VMs, and we were like, "This is the VM we're going to make debuggable." And I became a huge Parrot fanboy, and then Parrot seems to have died.
Yeah, I remember I got off a flight having read the Perl 6 and Parrot book, I was bringing the good news. I really felt like this was the gospel.
Have you heard the good news about Parrot? But Parrot, no.
That's right.
Parrot seems to have Parrot, and it's not Perl 6 anymore, right? It's whatever. What are they calling it? Perl 6 has been rebadged to Roku. No, Roku is what my kids watch.
Right. I'm in the same spot.
What is it? What is it called?
Raku, right?
Is it Raku?
Raku?
Is it? Yeah. God, it's like, hey, Perl 6. I'm sorry. It's still Perl 6.
If only there was some way that we could query the internet.
That's right.
It's Raku, R-A-K-U. I just looked it up.
R-A-K-U. I don't know. I'm sure it's me. That one's not sticking with me. I don't know. I think for whatever reason, Roku is squatting on those synapses. I'm sorry. Not that it, not deservedly necessarily. But I think we sort of keep these to about an hour. So I think we probably want to wrap it up. But this has been great as always. Thank you, everyone. Adam, any closing thoughts?
My closing thought, here's my shot, is that the end of Moore's Law is going to be the thing that motivates us to understand our systems better.
Ooh.
Because we're gonna need to start squeezing where previously we could just be lazy and wait for Moore's Law to do the squeezing for us.
Ooh, and that gets to Dan's point too. That Danny's preaching your gospel in terms of understanding what systems that don't perform very well.
But it's not just performance. I want to emphasize that. That was just an example. It's like, I want to understand the behavior of my system.
And
right?
the end of Moore's Law is going to force us to do that. I like it. Adam, how long have you been sitting on that the entire time?
About 5 minutes, yeah.
Don't lie, Adam. It's one of his little bullet points on a sheet of paper.
Exactly. I wrote it down this morning.
When I got up this morning.
Wait a minute. Adam was the one that said, "Have you read Lobsters this morning?" Wait a minute. It's like the Spanish Prisoner. All right. With that, thanks everyone, and we'll talk to you next week.
Thank you.
All right.
See you. Cheers.